We've maybe given a little bit of a definition about what a molecular formula is, but now today let's go ahead and expand that a little bit more. So first of all, let's go back. Empirical and molecular formulas go together, okay? An empirical formula is the most reduced version of any chemical formula. Do you remember that? Empirical formulas are the most reduced version, okay? So I'm going to come write that up in the top here. Empirical formulas the most reduced version of a chemical formula. And a molecular formula is just the exact chemical formula. Okay, so that means that it could be reduced or it could be non-reduced. Okay, so the molecular formula could be a formula in which that is non-reduced. Okay, we're talking specifically about covalent compounds there, because with ionic compounds, we always reduce them down. But covalent compounds could have a lot of different variations, okay? But the molecular formula is the exact formula of some chemical. So let's say that we have a formula that looks like this, C2H4. Would that be a molecular formula or an empirical formula? This would be, can we reduce it down anymore? We can reduce it, so that means it has to be a molecular formula, right? It's the exact version of that. What would be the empirical formula of that particular example? What would the empirical formula be? How would I get that reduced to its lowest version? What would it be? Yeah. Good. CH2 would be the empirical formula of that particular sample, right? The ratio stays intact, but it's not the exact chemical that we're looking at, because these two chemicals behave differently. They have different properties and different characteristics, but their ratio happens to be the same. Okay? So let's jump into just some practice here with molecular formulas. So let's look at this first one given here. Okay, it tells me the empirical formula of a substance is CH2O. Okay, this is my empirical formula. The molar mass of my unknown compound, or the molar mass of my molecular formula, is 180 grams per mole. So I need to figure out what is the formula for my unknown compound, my molecular formula. Okay, and the way I go about that is the first thing I need to do is I need to find the molar mass of my empirical formula. Okay, I need to find the molar mass of my empirical formula. Okay, so grab your calculator and your periodic table out. So we have that out in front of us. And let's find the molar mass of CH2O. Okay, CH2O has a molar mass of 12 plus 2 plus 16, which gives me, I think, 30 grams per mole. Okay, so if my empirical formula has a molar mass of 30 and my unknown has a molar mass of 180, are they possibly the same compound? They can't be the same compound because they don't have the same molar mass. And so what we're going to do is we're going to figure out which version of CH2O is my unknown, right? Is it C2H4O2? Is it C3H6O3, right? It's some version of CH2O, but I got to figure out which one it is. So the way I do that is I take my unknown, or my molecular formula molar mass, 180 grams per mole, and I divide it by the molar mass of my empirical formula, 30 grams per mole. And this will tell me like how much larger my molecular formula is than my empirical formula. So I do 180 divided by 30, and I get 6, right? So that's just telling me that my unknown compound is 6 times larger than my empirical formula. Okay, it's 6 times heavier. And so what I do is I take that 6 and I just distribute it through CH2O, and I get C6H12O6. This is my molecular formula. Okay, I'm looking at how much larger my unknown is compared to my empirical formula, right? Empirical formula was given to us in this problem. My molecular formula, my unknown compound, we knew its molar mass, and so we were able to compare and find that ratio. Okay, so I do my division. I always take the bigger one divided by the smaller. That tells me how much larger it is. I take that times my empirical formula to get my molecular formula. Okay, I know we're saying a lot of like big words that tend to run together, right? Empirical formula, molecular formula, all that kind of stuff. But we're gonna keep those in 2 categories, right? Empirical formula is the reduced, and molecular formula is the maybe non-reduced. Okay. Could there be a scenario in which my unknown and my empirical formula are the same compound? Yeah, that could work, right? I would know that if my molar mass were the same, right? If my molar masses came out to be the same. Okay? Let's go ahead and try the next one here. It says a sample contains 1.388 grams carbon, 0.345 grams hydrogen, and 1.85 grams oxygen. The molar mass of our compound is 62. What is the compound's molecular formula? Okay. But the problem is they didn't give me the empirical formula, which means I have to find that first. So we need to go back to those steps we wrote out about the empirical formula. Okay. Can you locate those steps in your notes? Okay. If I want to find the empirical formula of this, my first step would normally be to take percents and label them as grams. But do I have to do that in this problem? Nope, because my starting amounts were already in grams. So I'm going to have 1.388 grams of carbon, and I'm going to convert to moles. 0.345 grams hydrogen, and I would convert to moles. And 1.850 grams of oxygen, and I would convert to moles, right? I'm going to take each of those grams and convert to moles. So let's go ahead and do that for each of them. In this step, when we convert to moles, should they come out at nice, pretty whole numbers? Not at this step. So we want to keep some decimals here with this step, okay? Okay, do those values look similar to what we had? Okay, now we've got them each in moles. Our next step is to, what do we think? Divide them by the smallest number of moles. And so don't we think that these two are pretty much the same? Right, so we're taking each of them basically divided by 0.1156. So that would tell me I need 1 carbon. 0.1156. I'm assuming that's going to come out at 3. Okay, so I need 3 hydrogens, and I'll take this one divided by itself to get 1 oxygen. So my empirical formula is CH H3O, right? This is my empirical formula. But I can't stop my question here, right? It asks me for an unknown molecular formula. Okay, so now I'm to the part of my question that I was at, like in our last one, right? In our last question, they gave us the empirical formula, but this time I had to solve for it. So now I need to find the molar mass of CH3O, right? Carbon plus 3 hydrogens plus oxygen gives me 31 grams per mole. And so are my molecular formula and my empirical formula going to be the same in this case? Based on the fact that it says the molar mass of my compound is 62. You think they're going to be the same? Do they have the same molar mass? No, right? My unknown has a molar mass of 62, but my empirical formula has a molar mass of 31. So I'll come down here and I'll take the larger divided by the smaller. And it says my unknown then is 2 times larger, right? I come out with a 2. So it's 2 times larger than my empirical. So 2 times CH3O gives me C2H6O2 would be my molecular formula.